So hello and welcome to a short tutorial on how to build a Peterborough FET timer for Ferry 500. So the Ferry 500 is an E20 electric free flight class with a maximum wingspan of 20 inches and a maximum length of 20 inches. In the PMFC we fly a restricted class which gives a specified motor, timer and battery, which gives a nice level playing field for relatively simple electric free flight. So just to demonstrate the timer, the motor run is set at 8 seconds, which gives about 20-30 meters of height on a good climb, and we fly to a max of something between 45 or 60 seconds. The reason it's a short run is because we fly in quite a small field. You could modify the timer for a longer run if you wanted to. So the timer is started. This is the timer here. Is actually started by touching the contacts with a 9-volt battery, a PP3. So just to talk about the basic components specified, we have a GWS Style 3x2 prop. You can't actually get GWS anymore, but Turnigy and Gemfan make a copy. It's fairly available. The motor is a brushed 12mm can motor. It's a GWS CN12-RXC. Again, these are hard to find, but there is now an alternative, which is the N60 motor, which you can find in China via eBay. The timer here is made up of 4 basic components and is fairly simple to solder together. More details on that to come. And the battery is a 2S 180 milliamp hour Lipo. And obviously the PP3 is just a standard alkaline battery. So let's have a look at the timer in a little more detail. There are 4 components that make up the timer. From left to right we have the field effect transistor, or MOSFET. We have a capacitor. This is a surface mount SMD capacitor. A resistor, and a Schottky diode, which gives us polarity protection. And the 4 of those are assembled together on a JST Pigtail. This is just for convenience really, because the 2S battery fits the plug on the pigtail. So the MOSFET works very much like a switch. If you apply a voltage to the gate terminal, this one here, the switch will close and the motor will turn on. Once you remove the voltage, then the motor will turn off again. So we need some means of applying a voltage to this terminal. Now this is provided by the capacitor and drained away by the resistor. This means that when you charge the capacitor from the 9-volt battery, when you zap the timer, the FET will turn on and the capacitor will hold voltage on that gate terminal until the resistor drains it away. So you can see that the resistor and capacitor work together to give us voltage on the gate for a set time. Now you can change the time of the motor run by varying the capacitance and varying the resistance. More resistance takes longer to drain away the voltage, gives you a longer time, and obviously more capacitance takes longer to drain away. These components are fairly large. They're not the smallest you can build the timer with, but they give us our 8-second run with a 47 UF capacitor and 120k resistor. The Schottky diode, this side on the right, is just polarity protection for the timer. If you accidentally reverse the polarity when you zap with the 9-volt battery, you can actually blow up the capacitor. So that just provides a little bit of reassurance. The timer will not start the motor if you have the battery on the wrong way round. polarity is important in certain elements within the timer. If you look closely here, you can see that there is a stripe on the SMD capacitor. That is the positive side, and also the diode has to have the black stripe towards the timer. That allows it to charge. I add a little bit of insulation from a wire onto these terminals, red for positive and black for negative, as a reminder for how to use the PP3 battery. But because we have this Schottky diode, it won't work the wrong way anyway. It's also worth noting that the timer is inserted into the negative wire from the battery, not from the positive one. You may have noticed earlier in the video that the motor had its wires reversed, the red and black reversed. That is because we want counterclockwise rotation from the motor, but it is essential that you put the timer in the negative battery wire. So moving on to soldering equipment, really nothing particularly special at all. My soldering iron is, I think, like a £10 one from Maplin's back in the day. You can certainly get these on eBay or Amazon for something between £10 and £15. Really nothing special, except just make sure it's a good clean tip. For cleaning the solder off the tip, I've got some brass wool. There's various ways of doing that, but it's just part of good practice to keep the tip clean and makes life a lot easier. Solder, it does help to have a small diameter solder. I think this is about 0.8 millimeters. It's just much easier to control than heavier stuff. But a good small solder is always useful. Liquid flux or a flux pen can be very helpful. I actually find that I don't need to use flux, but it does certainly help the solder to flow better and requires less time heating the components, which is something to bear in mind. A nice simple pair of tweezers. These are the grabby type where you can let go and it still holds on. And the real key to doing a good job of these little timers is to make suitable jigs for them, so that you don't have to worry about picking up the item with capillary action. We'll talk more about jigs later, but really nothing particularly difficult. Most modelers will have this kind of equipment if they do a little bit of electronics or perhaps radio control.